we are continuing with solving equations today. There's a lot of review in this lesson, so if there was something maybe yesterday that you didn't get so well, maybe it'll help today. Starting with this first problem. So again, all we're doing in yesterday and today is solving equations. Solving equations, they're just fancy equations, but we want to get x by itself. That's our whole goal. And the problem is x is hiding somewhere difficult, like attached to a log or up in the exponent. And this one looks really pretty crazy, but I can promise you it's really not. If you look at it, it's kind of like a quadratic. It's something to the power of 2. There happens to be something else up there. But it's a quadratic style problem, although it looks a little strange. So what we do with these types of problems is we're going to use some of our algebra skills like this. I'm going to take out anything that is an e to the x, and I'm going to call it some letter. I'm going to call it u. U is typically what's used in these problems, okay? So what I'm going to do is use substitution, and anywhere I see an e to the x, I'm going to replace it with a u. Why am I doing that? I'll get to that in a second, okay? So in that first term, I have e to the x with a 2 in there, so the e to the x becomes u, but the 2 is still there, so leave it there, okay? And then minus 3, there's another e to the x. I'll make that u. And then minus 4 equals 0. Okay? So what we did right there is just change the problem slightly following the laws of math, algebra, substitution, just to make this a little bit more, a little easier to factor. And we'll come back to how we incorporate this back in a minute. So let's just go ahead and factor this. This is a quadratic trinomial. This is one of your chart problems, but an easy chart problem. And you can make a chart, or you don't have to. So, I mean, you probably can guess I don't ever make a chart when I'm factoring myself. I'm just trying to help you get away from doing that. If you want to, you can always show more work than you need to. So anyway, what I'm looking for here is the two numbers that multiply to get negative 4, add or subtract to get negative 3. So starting with the 4, I only have 2 sets of factors, right? 2 times 2, but that won't make a 3 in any way. And 4 and 1. 1 and 4, 4 and 1, doesn't matter which one you put first. And then to get a negative 3, I would have to make the 4 negative. Does it matter? Yes, it does. If it was hard for you to do in this method, of course you can go off to the side and make your chart. Whatever your method is, you have to know how to solve it, factor it. So this is my factored answer. Let's set them equal to 0 and solve. We would get these 2 answers, okay? But those aren't our answers. We're trying to solve for x, not u. Remember, we just substituted u in for the e to the x's. Let's now put it back to what it was. U is actually e to the x. And now we're back into like what the traditional problem was, and we can solve for x. So, just like yesterday, you're asking yourself, what do I have? A log or an exponential? This is clearly log equations. I'm sorry, exponential equations. And to solve these, I would first see if I could get like bases. So let me just remind you, you don't have to write this. We're not doing this problem. If I gave you like 3 to the x equals 17, that's an exponential function. We can't make a 3 and a 17 have a same base. Yeah, we can't make a 3 have a 17 or 17 have a 3. So remember what we learned yesterday is this new method of giving both sides a log base 3. Why did we use a log base 3? So that would cancel and we could bring the x down. So whatever this base is, that's the base of our log. Well, in this problem, our base is e. What are we going to use that has a base e? ln. Yes. So I'm going to give both sides an ln. Remember, you can do anything you want as long as you do it to both sides. So I gave both sides an ln. Again, and you sounded like you guys knew that, because natural log has a base e. So by putting a natural log in front of an e, we get to cancel that, and the x comes to the front. Understand why the x comes to the front? Very simply because of the power property. It's not only that if there's a number in front, we can write it as an exponent, we can go backwards, right? We can go back and forth. And then let's put this in our calculator. And when you do, you will get an error because you can't have a negative log. Remember, ln is an log. Natural log is a log, okay? So we learned yesterday, day before, I don't know, that x has to be greater than 0. In other words, positive, right? That's the same for a natural log because they're logs. Everything that happens to an log applies to an ln, okay? So the minute you see that, you should know you're going to get an extraneous answer here. Really, at the minute you see this, you might even recognize it, okay? But if you didn't, you would do this work and you would figure it out very quickly that that is not a good answer, okay? Then let's do the same thing to the the right one. Natural log e to the x equals natural log 4. Natural log e cancels, x comes down. That's as much as I can do to that equation by hand. In other words, x is by itself. I've moved everything to the other side. Anything else I do, I have to go to my calculator. So that's my exact answer. And then natural log 4 in my calculator, rounding would be approximately 1.386. Okay? I gave you one of these in your homework to do. It's number 1 in the homework. I'll do it with you just to remind, just so we don't have to do more in the notes. Let's move on if you don't have questions. Example 11 and 12 are 2 log equations like what we did yesterday, okay? I don't know if you remember, but yesterday when I taught you how to solve log equations, I told you there's 2 types. There's 2 different types. And luckily, we have one of each today, so review of yesterday. Now, I will tell you example 11 is the long type of factoring, and I'm going to go kind of slowly in this problem just to make sure if anyone is, because there's a lot going on in this problem, I'm going to go pretty slow with it. So please do me a favor and stay with me. Don't put your heads down. Don't tune out. I did not give you one of these in your homework because they take a while. And I'm just kind of counting on you guys to do this one with me, kind of remember everything, and then I gave you easier ones to do in your homework. Okay, so just do me a favor and stay with me. So first thing I look at with this problem is I say, okay, this is a log equation, and I have to solve this equation. First thing, then I would notice that I have an expanded log on one side. Expanded means more than one log. We have to condense it, make it a single log by applying our log property called the product property. Remember, addition and multiplication go together. So I'm going to write ln one time, and then I'm going to multiply 3x minus 2 times x minus 1. I'll do that in a second. On the other side of the equation, I can apply the power property. Remember, if a number is in front, I can rewrite it as an exponent. Okay? Now I'm going to multiply this. Now, earlier in the day, I did that pretty quick. It's just FOILing. And I don't mean to ever talk down to you like, it's just FOILing, you should know how to do it. I kind of take for granted sometimes that you guys just remember stuff, and maybe I need to slow down a little bit. My first period is very good about teaching me that. After 29 years of teaching, I forget things sometimes. I'm just going to FOIL this out a little bit slowly, just in case there's even one person here that struggles with that. So I'm just going to use this space up here, because you know I write really big. So I'm just going to go up here and do the work. FOIL, distribute. Depending on who you had for Algebra 1, they called it different stuff. But I'm just distributing the 3x to everything in the other set of parentheses. So 3x times x is 3x squared. 3x times negative 1 is negative 3x. Done with the 3x. Do the same thing with the negative 2 times both of these. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. And then you always write your answer in standard form. Remember what standard form means. Exponents in descending order and combining any like terms if you have them. Edgar? Edgar? Anybody want to take a share? Thank you. You need to stay awake. All right, so I have natural log 3x squared minus 5x plus 2. So I just put it back in. We get with FOILing. If somebody's really, you know, I think of that as something super easy, all of you can do, but maybe you haven't done it in a long time and you forgot, okay? So please understand, don't ever be embarrassed. If you have a question, I will come and help you when I'm walking around, okay? So just remember you need to ask me about that. Okay, now, we did the cleanup of the problem. Now we're ready to solve it. So two things can happen in a natural log problem. And this is one of them, obviously. And that is when you have logs on both sides. When that happens, you can cancel them because natural log equals natural log, which means 3x squared minus 5x plus 2 equals x squared. And now I'm going to use my algebra skills and solve this. This is a quadratic because it's got x squareds in it. So when I notice that, I say, okay, I've got to get everybody on one side of the equation together, and then I'm going to have to factor it. So this is a step I wouldn't normally show, which you don't have to either. You could do that in your head, just moving everything over. Remember, you want to get a 0 on the other side, and factor it. This is a quadratic trinomial, also known as a chart problem, and it has that leading coefficient that's greater than 1, which means it's the longer method. So I'm going to go a little bit slow with this to remind you how to do it. So we multiply a times c, 2 times 2 is 4, and then my middle term, the b value, is negative 5. Do your magic, find your two numbers. We need the two numbers that multiply to get 4, add or subtract to get negative 5. Well, the only factors of 4 are 2 and 2, or 1 and 4. 2 and 2, there's no way to make a 5, so I'm pretty sure 1 and 4 are my two numbers. Make your decision about signs in this column, because it doesn't matter over here. There's two different ways you can write that. Here, how do I make a negative 5? There's my good factorers. Negative, negative, right? Both negative. Makes a negative 5. But just always check the other column as well. That's a good way of making sure you didn't make a mistake somewhere else, okay? Does negative 1 times negative 4 equal positive 4? Yes, it does. So those are our numbers. But because of the 2, we can't just go x minus 1, x minus 4. That's a common mistake. Don't forget, because of the coefficient, you have to bring down the outside two terms and split the middle. We split the middle into these two numbers. It doesn't matter which one goes first, but you do have to give them both an x. Understand why. Let's talk about it, make sure we understand. I just split negative 5 into those two numbers, negative 5x. So if I leave off the x, I didn't really split that into two. These two numbers in green should equal what's above it in blue. Okay, that's why you have to remember the letters. And now we have the type of factoring where there's 4 terms. Whenever there's 4 terms, we do the grouping. 2 and 2. And then we GCF this. I can take an x out of the first set of parentheses, that's all. Don't forget that when the third term is negative, or let me say it differently. Whenever the first term in any set of parentheses is negative, even here, you would factor out a negative. And they would have a 2 in common. If we did this right, our parentheses should be identical twins, which they are. That's one of my factors. And then the GCFs are the other. Listen, nobody likes to do that factoring, even me. It's annoying. It's a lot. It's not fun. And we don't see them very often. We see the shorter type all the time, right? But these we don't see very often, but we still have to know how to do it. Okay, we are still not done because we have to solve the equation. That's what we're doing. This is just factored. So set each of these equal to 0 and solve. So we get 1/2 and 2. Now, don't forget this very last thing we always have to do with a log equation is to check if our answers fall. Did someone say wait? Did you say wait? Huh? I thought you said wait. Oh, all right. Do you have a question? Okay, sorry. I thought you said wait. We have to make sure our solutions fit within the domain. Logs are very particular. Remember, that number that's right there can't be negative, okay? So here's the mistake. Everybody listen. This is the most common mistake. What many students do is they look at these answers and they go, they're both positive. I'm good. 2 solutions, moving on. But I'm going to tell you, and I'm going to prove it to you in a second, that 1/2 is not part of our domain. Here's why. So let me go over this with you. I really need you guys to understand this. I'm going to show a bunch of work. You don't have to show this work, but I want to make sure you understand it. Anywhere there's an x attached to a log, we have to be aware of the restrictions that poses, okay? There are 1, 2, 3 x's, so there are 3 places we have to make sure our answers work, okay? So I'm going to use this space over here. Someone looks at my notes without the video, they're going to be like, what the heck is she doing? So remember, it's not that x has to be positive, it's that whatever you plug in here is, and simplify it, is positive. So that's why you see me doing this. 3x minus 2 has to be greater than 0, right? Whatever we get there has to be positive. This has to be positive. This, okay, that's already just saying positive. So in your head, writing it out, whatever you want to do, you would want to simplify these. So for this part of our domain, x has to be greater than 2/3, x has to be greater than 1, x has to be greater than 0. Mentally, write it out, whatever works for you. Think of the number line. Okay? So some of the problem will accept numbers from here on, some of them from here on, and some of them just from here on. Remember, it doesn't matter about these numbers because it has to overlap. What all of any of our solutions, any of our x's have to work for all 3 of them. So the easiest thing to do is find the biggest number. We want all the numbers greater than 1. So that's why 1/2 does not work. 2 is your only solution. One more thing just to prove it to you. If I plug a 1/2 in right here, I'm going to prove to you that even though it's a positive number, when I plug it in, I would get a negative number. And we know that that's bad. So there's an example of why sometimes a positive is not good. Okay? Do we understand that? You have to check it. You don't have to show all this, but you have to understand that whole concept. Okay? Good? Okay. Another log problem. Again, take a second, look at it. I've got an expanded log on one side. I've got to condense it using my properties of logs. I write log base 3 one time, multiply x by x minus 8. You could have absolutely skipped that step if you wanted to and gone right into distributing. Okay, so that gives you the cleanup, guys, pay attention. That gives you the cleanup of the problem. Now you say, how do I solve it? Okay, so 2 things can happen with log equations. We saw the first one here. Logs on both sides, they cancel. That clearly is not going on in this problem. We don't have logs on both sides that we can cancel. So we go to our standby method of rewriting this log in its other form. Start with your base, power to the other side equals that. I like to have my x's on the left-hand side. So I just did my 3 squared, which is 9, equals that, and I just switched it. But you do you. Again, when I get to the step, I notice it's a quadratic. I've got to get everybody on one side together. So I'm going to subtract 9 from both sides and factor. This is the quick factoring. We should be getting better and better at factoring because it's been coming up a lot lately. And I promise you, if you're going to take math ever again in your life, you'll have to factor again. The 2 numbers that multiply to get negative 9, add to get negative 8 are going to be 9 and 1. Who's negative? 9, right? If you need the chart, do the chart, set them equal to 0 and solve, and we get these 2 numbers. Be careful because this is a log equation. We have to remember to check the domain. So going back to the original problem, x has to be greater than 0, and x has to be greater than what? What number goes here? 8, right? Set that greater than equals above. So the bigger number is 8, so I will only accept any numbers greater than 8. So that gets rid of the negative 1, keeps the 9. Okay? Good? Okay, the hardest part is over. 2 more things to show you, really easy. Example 13, just part A. Formula we've seen many, many times. You have deposited $1,000 in an account that pays this much interest, compounded continuously. You hear that magical word of continuously, and you should remember that that's your PERT formula. It's on your formula sheet. You can find the balance. Balance is the A part of the formula. Okay? You can find the balance in your account using that formula. And there's, guys, stop. One more letter in there, T is time. So use this formula to find time. Find time. So T is what we're trying to find when the balance is doubled. Okay? And Jean, the lady that makes these notes, already kind of plugged some of the important stuff in. $1,000 is your principal. E is a button on your calculator. The percentage rate is already plugged in, and we have to find T. So the amount in your account doubling would mean what I put in was 1,000, so doubling it would be 2,000. Now, let me tell you ahead of time, this problem, you have one of these to do in your homework, and I did not show all the steps because you don't really need to, but if you get stuck on the homework problem and you're wondering how I did any of the steps, I am showing all the steps in the notes, okay? And that first one is this. Sometimes we just look at them and it looks like a foreign language. Like, what am I even looking at? So just stop and say to yourself, is it an exponential or a log? An exponential function. And to start an exponential function, I need the base by itself, okay? I need the base alone. This 1,000's got to go, right? So this is a step I wouldn't normally show, but I'm showing it here. Divide both sides by 1,000. That gives me 2. Okay, I cleaned up the problem, and then I say, how do I solve an exponential function? I first see if I can get like bases. I can't get a 2 and an e to be the same base, so I use the other method, which we did in the very first example. Whenever we have an e, we can just give both sides an ln. ln2 equals ln e to that power. Again, why did I do that? Nice and simple, because there's a base e here. These guys cancel. This comes to the front. So I have natural log 2 equals 0.065t. Remember your goal. The whole time you're trying to get x, in this case t, by itself. Here's another step I wouldn't show, but you don't have to either. This is multiplication, so I'm going to divide both sides by 0.065, and that'll get me my t. Now, this is an exact answer, right? This is, I've done everything I can until I go to my calculator, but this is a word problem, guys. You went to your bank and you asked them, how much time would it take? Your banker is not going to tell you, it'll take natural log 2 divided by 0.065 years, okay? So common sense is, yes, you would have to go to your calculator and find the actual answer. So that's natural log 2. Make sure you close the parentheses, little things like that, right? Because if you don't, it's still going to be in the numerator with the 2. 0.065, and I get 10.664 as my time, okay, rounding to 3 places. What if it said how many years? What would you say? 11, right? 10 years plus a little more. We've talked about that in other, whatever. So 11 years, or 10.664. Okay? Last thing is just to remind you of something. We went over how to put these in our calculator. How do I solve an equation in my calculator? I use the intersection. So when you go to example 14, ignore all the directions. This is like number 9 and 10 in your homework. It's going to have all that mess. Ignore it. I just want you to practice finding a solution using your graphing calculator. Okay? Really, really easy. But I'm going over it again because it's important, and there's something a little strange about B. So we're going to do A and B really quickly, and then I'll be done. Someone asked me earlier today, couldn't I have done this one in my calculator? Couldn't I made this y1 and this y2? The answer is yes. You could have done this in your graphing calculator in like less than a minute, gotten this answer and walked away. Like I said yesterday, remember the $1 million question? That's great for checking, but like on my quiz, this is an example of something you would have to show your work. Okay, so you have to know how to do this. Use your calculator as a backup. But in a question like this, it's just use your graphing calculator, find the solution. Okay, so we always want to clear our RAM. Don't forget to do that. And then type these in. So this would be e to the 2x and 60. Super simple to type in, right? Graph it. When it finishes graphing, we're going to go to intersection. Oops, intersection. And do you remember yesterday I said intersection is the easiest thing in the world? You just hit enter, enter, enter like this. 1, 2, 3, and you get your answer. Yes, great. I should know after 29 years of teaching that I should never say it's always. I should never use the word always in this class. Because I have learned, why haven't I learned, but I've learned that there's like always an exception to the rule. And here's an example of that, okay? So let me explain what I mean. So pay attention, clear your RAM, and let's put this one in, and I'll explain to you what I mean. Easy fix, easy fix, but we have to talk about it. Okay, so y equals 2, and remember how to put a log with a different base in? Math, alpha, math. Graph, give it a second to finish. Go to intersection. And what I told you yesterday is these are the best. You just hit enter, enter, enter. But look, when I'm hitting enter, 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 nothing's happening. Okay? So, and it seems to happen on some of these log problems. I know why it's not working on this one, but number 10 in your homework, the same thing is going to happen. I'm about to show you, but I'm showing you right now. And I have no idea. So if anybody gets to number 10 and wants to explain to me why you think, I mean, I've been asking my students all day, none of us can figure it out. But don't worry about it right now. So why is it happening on this problem? Because our intersection is not in our viewing window. We need to move our window over, okay? So I'm going to go to window, go to X max, and change it to something. You know, I'm going to put 20 in. The worst case scenarios, you don't go far enough. So maybe you want to be more aggressive. It just depends, okay? Worst case scenarios, I have to go back and go further over. So now you'll be able to see the window, and see the intersection. And now when I go to my intersect, it works just fine, okay? So we get X is approximately 10.392. Now listen, that makes sense, right? Because when we default our calculator, our screen, we clear the RAM, it goes out to 10. And our intersection was past 10. That's why it didn't work. I'm going to tell you, number 10, the answer is like 4 point something. You can see the intersection just like this on your screen. I don't know why it doesn't work. You can do two things. You can change the window. That works. For some reason, changing my window to go further to the right made it work. Or you can go to the old-fashioned thing you do with mins and maxes and stuff and use your arrows to just go move your cursor around. If you get to number 10 and you're stuck, call me over. But I'm just telling you, the same thing happens. Always just try to do the enter, enter, enter before you mess with your window, because 99% of the time that will work. Okay? Good? Good. Good talks, guys. So communicative today. All right, page 155. Please write the assignment down, because then I'm going to do number 1 with you. And then I'll shut my mouth. Write it down, write it down. And I just want to do number 1 with you because it's brand new, and we only did 1 in the notes. Okay. So first thing you should notice is it's one of those like quadratic-y looking problems, so I knew I had to get everybody on one side together, so I went ahead and subtracted the 42. And I'm going to let e to the x equal u. Factor. Is that my door? What two numbers? Multiply to get negative 42. Oh my God. Two of my favorite. They want them now. Oh. Yeah. Woo! Unit 3 coming at you guys. Thank you so much. I got it. I hate you guys at part. This is not the part. I know you guys want this part back.
Yeah. So I can use that.
But there's one that says not the part. Okay. I don't know. I mean, it's not urgent to me, but if it's urgent to me,
yeah, we have another part too.
Okay. Don't be scared. That's the first half of Unit 3. There's still another half. Okay, what are our two numbers, guys? What multiplies to get 42? And 1. 42 and 1. 7 and 6. Make the 7 negative, the 6 positive. Yes, it matters. I did that quickly. If you need to make the chart, make the chart. Solve. And then you plug back in. That e to the x. Exponential function, we can't get like bases, so we're going to put a log on both sides to cancel the base e. That would be a natural log. Don't forget to do it to both sides. X comes down, natural log e cancels. There's your exact answer, right? And our approximated answer, this one's bad, right? If you get a negative number there, you'll end up with x equals natural log of negative 6. Can't have a negative there, so you'll get an extraneous thing, okay? Anybody still writing number 1? Yay, it looks